Redox, balancing of redox equation to us. Let's go. Now the question here says we should calculate the charges in the oxidation number of the following atoms in bold print at the beginning and at the end of the following reactions, and hence determine whether reduction or oxidation has occurred. Let me clean this. Okay, we have 2KMnO4 gone to K2O plus MnO2 plus 5O. Mn is bold, and the Mn there is also bold. They say we should calculate the changes in the oxidation number of the following atoms in bold print at the beginning and at the end of the following reactions. And we should tell if it is oxidation or reduction. So this is the KMnO4 in the reaction, which is the compositional reaction. We have our Mn here. So we want to know, does the oxidation number of manganese here increases or decreases? If it is 2 here and we have 3 here, then it increases, so oxidation takes place. If it is 5 here and it is 2 here, it reduces, reduction takes place. So let's start. We'll find the oxidation number of manganese in this compound. So I have 2KMnO4. All of this is equals to 0. Now, remember, this 2 means every element inside possesses what? 2. Yeah. So I have potassium here in bracket. Potassium is 1 plus manganese plus oxygen is minus 2 times 4, all equals to 0. Now, let me expand now. 2 times 1 is 2 plus 2Mn. Plus times minus is minus. 2 times 4, 8. 8 times 2 is 16. All of this, okay, is equals to 0. Now, 2 plus 2Mn is equals to, this crossover become plus 16. Now, I want to take this across 2. So I have 2Mn is equals to 16 minus 2. 2Mn is equals to 14. Divide both sides by 2. Mn here is equals to plus 7. So the oxidation number of manganese here is plus 7. Let us see it this way. So I have my MnO2 is equals to 0. The oxidation number of all the elements in the free state is equals to 0. In the compound. So manganese is what I'm looking for, plus oxygen is minus 2 times 2. Yes, it's equal to 0. So this is manganese, plus times minus is minus, 2 times 2 is 4. All equals to 0. So manganese is equal to this crossover becomes plus 4. So the oxidation number of manganese in this compound was 7. When we, from the reactant, the product side is plus 4. So it reduces. So there is what? Reduction. That's what the question asks. That we should explain the changes in the oxidation number of the following atoms in bold print at the beginning and at the end of the following reaction, and hence determine whether reduction or oxidation has occurred. So in this case, reduction occurred. Let's take another one of such. So, in bold print as usual, we have F2 plus, okay, gives us F3 plus. We say the oxidation number of any element is equal to the overall charge in that element or whatever it is. So here the dissolution number here is +2, here is +3. So here was 2 and here is 3. What happened? It increases, so oxidation takes place. Now let's solve the last one on this before we go to balancing of redox. So we have 2 potassium ClO3. This is, we're looking for that of chlorine. Gives us 2 potassium Cl plus 3 oxygen, moles of oxygen molecule. Let's see what happens here. The 2 will go all through. I can as well just strike out the 2 because it's uniform. But then let's see. This is my 2. Potassium is +1 plus chlorine plus minus 2 times 3. All this is equal to 0. This side is 2, open bracket, 1 plus chlorine, close bracket, is equal to 0. This is 2 times 1, 2 plus 2Cl, plus times minus is minus, 2 times 3, 6 times 2, 12, all equals to 0. This is 2 plus chlorine, is equals to 0. Okay, make this the subject, so 2Cl is equals to 12 crossover become plus 12, 2 crossover become minus 2. And this is Cl is equals to 2 crossover become what? Minus 2. Now, this is 2Cl is equals to 10. You have also by 2. Cl is equals to plus 5. And here is this. So what happens here? The oxidation number of chlorine here is plus 5. The oxidation number of chlorine here is minus 2. It reduces. So in this case, reduction takes place. So having said that, remember our initial arrangement is to balance what? Redox equations. So like I said earlier on, we cannot balance redox equation without a fair knowledge of what? Oxidation number or oxidation state of compounds or of elements. So as such, we have to start with oxidation number. So now we have a glimpse of what it is or whatever is associated to it. So let's move on to what? Our usual word, redox. Balancing of redox equation. In redox, it has its rules. I'll give you the rules, like I said, but I'll not write them down. The basic rules are as follows. Assign oxidation number to each atom which changes and calculate the change in oxidation number. Where 2 or more atoms change oxidation number in the formula, calculate the total change in oxidation number in the formula. 3. Balance electron transfer, that is the gain and the loss. 4. Balance oxygen atom by 1 H2O molecule. Balance each hydrogen atom by 1 hydrogen ion for acidic solution and OH negative for an alkaline solution. 6. Balance the charge by adjusting coefficients on inspection. So there will be questions that through inspection we'll be able to balance it. So let's take our first question to balance the following equation. Number 1, in balancing of redox equation. Question number 1. Mn O4 minus plus iron 2 plus gives us Mn2 plus iron 3 plus. Okay, I think we're correct. So let's balance. This is a redox what equation. Now, the first thing we do is to calculate the oxidation state of each of these either element or ions or compound and so on. So here we go. Let's start with this. When I'm done calculating the oxidation number, I'll put the value here, then maybe clean the calculations. So I have MnO4 is equal to -1. As usual, remember the oxidation rule. So manganese is what we're looking for, plus oxygen is -2 times 4, all equals to -1. So we have manganese, plus times minus is minus, 2 times 4 is 8. This is equal to -1. So manganese is equal to -1, this crossover becomes +8. Then manganese is equal to +7. So here oxidation state of manganese in this compound is +7. Here is plus what? 2. It's equivalent to the charge. We said so earlier. +2, and here is +3. Do we remember that rule? The oxidation rule. Let me read it again so that you know why it is so. I said earlier on, in simple ions, okay, the oxidation number is equal to the charge on the ion. So the charge on this ion is +2, here is +3, here is +2, so the oxidation number is equivalent to that. So now I have the oxidation number, so I can take this out. You see the reason why you must have a fair knowledge of oxidation number in order to balance what? This redox equation. So now I am off with this. Now the next thing is, we're dealing here contains manganese, here manganese, iron here. From the product side, we have +2. From the reactive side, reactant, we have +7. So 2 minus 7 give us what? 5. Ignore the charge, so we call it 5. It's supposed to be -5, so let me just call it manganese. For the manganese sake, we have 5. -5, but it's +5, you ignore the charge. Now this side is 3 for iron, so let me call this iron. 3 minus 1, 2, sorry, is equals to 1. So this is the second step, where you've gotten oxidation states. The manganese in the left, the reactant side to the product side, you do your subtraction from the product minus that of the reactant, whatever you're left with is there. So the same thing goes to the iron. 3 minus this will give us 1. The next step is you cross multiply. Manganese have 5. So now wherever you see iron, you put 5 before it. Whenever you see manganese, you put 1 before it. That's just that. So now manganese is 5, iron is 1. So now manganese here, I'll have 1 in front of it. Manganese O4 minus 1 here is the same thing. Plus iron, we'll now take that of manganese, which is 5. So I have 5 iron 2 plus. This gives us manganese is 1 in now. So we have our manganese 2 plus iron is 5 iron 3 plus. Now, having done this, we balance for oxygen in the right hand side. We have 4 moles of oxygen, yes, we have to put 4 oxygen this way by introducing what? Water. For water contains oxygen. So now I can have this to be manganese O4 minus plus 5 iron 2 plus gives us manganese 2 plus 5 iron 3 plus 4 moles of water. So by this, 4, oxygen has 4, so oxygen is balanced. But in the course of we introducing our oxygen, we also introduce what? Hydrogen. So we have to balance hydrogen in the left hand side of the equation. We have 4 moles of, hydrogen, 8. So now I will add 8 hydrogen ions in the left hand side of the equation. So I have my manganese O4 minus plus 5 iron 2 plus 8 hydrogen plus. This will give us manganese 2 plus 5 iron 3 plus 4 H2O. Now, having gotten to this level, balance what? The charges. 1 times minus 1 is minus 1. Plus 5 times 2 is 10. Plus 8 times 1 is 8. 1 times 2 is plus 2, plus 5 times 3, 15. Now, 10 plus 8 is C minus 1. I have 17. Plus 15 plus 2 plus 15 is 17. So I have plus 17. Just call it 17. So now we say the equation is what? Balanced, because the left hand side is 17 and the right hand side is 17. So the redox equation is balanced. So this become our equation, which we can use in the redox reaction. In case we are dealing with titration, we have to know the number of moles of manganese and that of the oxidizing agent and the reducing agent. The oxidizing agent now becomes 1. The reducing agent is 5. The number of oxidizing agent to the number of reducing agent. So that's what it is. So we are balancing. So without the knowledge of balancing of this whole thing, in the course of doing that calculation, you're not going to get it right because you don't know the number of moles of the oxidizing agent and the number of moles of the reducing agent in the equation of reaction. So we're good with one. Let's take another one. Okay. Question number 2. It says we should balance the equation. Manganese O4 minus plus H2S hydrogen sulfide give us manganese 2 plus sulfur. So, what is the oxidation number? We just calculated this one earlier on. Is plus 7. The first one we calculated is plus 7, so it's the same thing. So we have oxidation number here plus 7. Here is, let's calculate this one. Hydrogen H2S is equals to 0. Hydrogen is 1 times 2 plus sulfur equals to 0. 2 plus sulfur is equals to 0. Sulfur is equals to minus 2. So here oxidation state is minus 2. Here is plus 2. The oxidation number of elements in their free state, in their neutral form, is equals to 0. So here sulfur is 0. I read that. I don't know, I don't have to go back to it. You have to listen or go check it out. So now this is what we have. We do our subtraction as usual. Manganese here, 2 minus 7 is 5. So I have manganese is 5. And let's call it sulfur. 0 minus this is still minus 2. So we ignore the sign, which is 2. So I cross multiply. Anywhere I see manganese, I put 2 before it. I see sulfur, I put 5 before it. So now, manganese here is 2 MnO4 minus plus 5 H2S equals to 2 Mn2 plus 5 sulfur. Okay, now let's see we balance for oxygen in the right side of the equation. We have 8 moles of oxygen here. So I have 2 MnO4 minus plus 5 H2S give us 2 Mn2 plus 5 sulfur plus 8. Alright, oxygen is what? 8 H2O. So now I have oxygen 8. But hydrogen now is 16. I have 2 MnO4 minus. Now, hydrogen is 16. I have to balance hydrogen this side. Plus, okay, now again. Since it's 16, and this side we have 10 hydrogen already. So I will bring in 6 hydrogen. Plus 5 H2S plus 6 hydrogen ion. will give us 2Mn2 plus 5 sulfur plus 8 H2O. Let's see, 2 times minus 1 is minus 2. Okay, this, there is no charge on it, so it's 0. This is plus 6. 6 times 1, we're balancing the charges. This times this is 4. 2 times 2 is 4, so plus 4. Now minus 2 plus 6 is plus 4. Plus 4. So we say our equation is balanced. As such, this becomes our official balanced equation, which we can use in redox or titration. So that's question number 2 in balancing of redox. Let's take more. Don't know the one they may likely bring. So let's take the third question here. We have MnO4 minus plus 5 iron 2 plus. Okay, give us Mn 2 plus 5 iron 3 plus. Like we balance something like this. Now this equation here looks a little different. Be that they have they've gotten the dissolution number. Then the dissolution number, after the dissolution number, they've done the cross multiplication, so we just proceed, which is going to be faster for us. So now, having done that, the only thing left for us is to balance for oxygen and hydrogen. So oxygen here is 4, so I have my MnO4 minus plus 5 iron 2 plus give us Mn2 plus 2 plus 5 iron 3 plus we have 4 hydrogen, so 4 H2O. We have 4 oxygen, sorry, so we have oxygen here now, 4. In the hard course of doing that, we have 8 hydrogen there, so put 8 this side. So I have my MnO4 minus plus 5 iron 2 plus 8 hydrogen plus give us manganese 2 plus 5 iron 3 plus 4 H2O. Let's check. 1 times minus is minus. 5 times 2 is 10. So we have minus 1 here plus 10 plus here is 8. Give us plus 2 plus 15. 10 plus 8, 18 minus 1, 17, and 17. Seems like they won't balance previously, but this one, they didn't start from the beginning. So let's take another question. I'll clean this one now. Yes. The third question will be the fourth. I think the fourth also. We have 2 MnO4 plus 5 C2O4 2 minus. This is a minus here, pardon me. Give us 2 Mn2 plus 10 CO2. So here again they've done the needful. All we need to do is to balance oxygen and hydrogen. Now, oxygen here, we have 2 times 4, 8. 5 times 4, 20. So 28 oxygen here. Oxygen, 28. Yeah, 10 times 2 for oxygen, 20. So we are going to balance for 8 moles of oxygen inside. So I come back, we have 2 MnO4 minus plus 5 C2O4 2 minus give us 2 Mn2 plus 10 CO2 plus 8 H2O. Now I have 8 oxygen now, so it's balanced. Now hydrogen this way, I have 16 hydrogen here, so I'll come back this way. I have 2 MnO4 minus plus 5 C2O4 2 minus plus 16 hydrogen plus will give us 2 Mn2 plus 10 CO2 plus 8 H2O. Okay, let's check if balancing of the charges. 2 times minus is minus 2. This is 5 times this is minus 10 plus 16. Give us 4. Is that all? Alright, let's see. Okay, good. Minus 2 minus 10 is minus 12 plus 16 is 4. And this is plus 4. So it's balanced. Let's move to another question, the 5th question, yeah? Okay, let's take this. 2 MnO4 minus plus 10 iodine minus give us 2 Mn2 plus 5 iodine molecule. So they have calculated the solution state and they've done the cross multiplication. So let's balance for oxygen. Okay, oxygen and hydrogen. Oxygen here is 8. Yeah. This is 10 iodine. So I have 2 MnO4 minus plus 10 iodine negative give us 2 Mn2 plus 5 iodine plus 8. So I have
8 moles of water.
Okay, 8 moles of water. And now I have 16 hydrogen. To introduce this, I have 2 MnO4 minus plus 10 iodine negative plus 16 hydrogen plus will give us 2 Mn2 plus 5 iodine molecule plus 8 moles of water. Let's balance it. Minus 2 minus 10 plus 16 give us plus 4 only. 12 minus 12 plus 16 is plus 4. This is plus 4. So the equation is balanced. Yeah. So far, with our acute knowledge of oxidation state, oxidation numbers, we'll be able to balance all redox reactions whenever we come across them, most especially during titrations. So I will advise you to go through what we've done now religiously, patiently, and go through them one after the other, solve them again, balance them on your own, and see that you get them right. And when you do, you'll be proud you actually did. Thank you, and have a nice day.